All right, for example number 6. Yeah, there's one thing I want to clarify here. It's the negative. I want to clarify with the negative here. And for this particular negative sign, what I want to clarify is this. First, I want to make sure that you view this properly. This is what it means. Okay. The exponent x, it's only going to affect the number 3, not affecting the negative sign. So the negative is going to stay in front at all times. Okay. So based on what we understood earlier, an exponential function is always positive, right? Without any kind of transformation. But then with a negative sitting in front, that means this y value will always be negative. Okay. So that's one way to interpret this. I must clarify this first. Now, the other thing I want to clarify here is that a regular exponential function, if it's a growth, it behaves like this. What does this negative mean? Or this negative? What kind of transformation it is doing to the graph? Reflecting over the not y-axis, x-axis, yes. Okay. So if it reflects over the x-axis, so any y value that would be going from positive to negative, then it becomes like this. Okay, so I want to make sure that you have a little bit of a conceptual idea of what it looks like. Now, we will not characterize this as a growth or decay, but I would characterize this, okay, this downward graph, as something you don't want to have. All right, let me give you a scenario. What this could be, what scenario would behave like this. Now, consider a student that has no idea about college, but this student decides to go to college. And this student does not have any saving or any kind of family support. So the way to pay for the college tuition would be to borrow money from the banks or from the government through the means of student loans. So that means right off the gate, the student is already in debt. Now, for students who have no idea in college what to do, they may spend a lot of time to party or to waste time, and they may not graduate in time in 4 years. And the later they graduate, they accumulate more debt. And the reason why it's very important to understand exponential function, because this could become a snowball effect. The debt could rack up really quickly. And since the student doesn't have any clue about college, he or she may not have a good job after graduation, so they may not make enough money to pay off the debt in a short period of time. Now, I'm saying this because it is very relevant to what's going on right now. A lot of people, they cannot afford buying a home, or they are not eligible to buy a home because they are still paying off their student debt. And the interest is pretty high for student debts. They are like 6 to 7% sometimes. All right. So now, anyone taking environmental science next year? Okay. Now, if you take environmental science next year, there's something called doubling time, or if you take human geo, I think they also talk about it, which is called the rule of 70. So if you know the percentage of increase, then you can tell how much it takes, how fast it takes to double. So for example, if the interest rate is 7%, you can simply do 70 divided by 7, meaning that if you don't pay anything, it's going to double in 10 years. So if you rack up like $100,000 from your college loans, then it could go up very quickly in 10 years. So again, make sure you are aware of this kind of graph. You don't want to let this be in your bank account at any time, okay? So with this graph, we still have the horizontal asymptote at y equal to 0. And for the x values that we propose, well, I'm just going to propose a 0, 1, and 2 in this case. Easy enough. So negative of 3 to the 0 power, it's going to be negative 1. So 0, comma, and negative 1 would be our first point, and that would also be our y-intercept. Again, making sure that the negative is not being affected by the exponent. I think that's a very key point right here. If x is 1, so a negative 3 to the first power would simply be negative 3. So right here, negative 3. And then negative 3 to the second power, negative 3 squared, it would be negative 9. So it'll be right here. So what you're going to do is to show the graph like this. Okay. So the domain, it's all real numbers from negative infinity to infinity. The range would be from negative infinity to 0. Now, do not write 0 to negative infinity. We always go from small number to big number. So from negative infinity to 0. Okay. So so this would be something you would anticipate on the graphing exercises. Okay.